In this video, we'll walk through an example of adding rational expressions. Now, adding rational expressions, adding or subtracting rational expressions, is the same as adding or subtracting fractions. And by that I mean that we want to find a lowest common denominator. So the process is the same, even if it's a little bit more involved and complex with the rational expression part. But the idea is the same. So we need a lowest common denominator. And to do that, we need to first factor the denominators so that we can see what factors are missing from the other rational expressions that we're adding. So we're going to factor this denominator. So I'll start with writing x minus 1 is still in the numerator, and in the denominator I have x minus 2 times the quantity x minus 2. So I've factored that denominator. The next one, x plus 3, stays the same. And I've got x squared minus 4, a difference of squares, so that's x plus 2 times x minus 2. We've got that factored. And then plus, you will see things like this in book problems or maybe even in a test where the factor is reversed. So you've got 2 minus x instead of x minus 2. So I'm going to bring this over to the side so we can work on it. We've got 2 over 2 minus x. Well, if I factor out a negative 1 out of the denominator, I get 2 over negative 1 times x minus 2. And you can pause this video at any time if you need to check and make sure why that works. But the nice thing about factoring is you can always multiply through to see if you factored it correctly. And yeah, negative 1 times x gives negative x, and that's what we have here. And negative 1 times negative 2 gives positive 2. And that's what we have here. So that is a correct factoring there. So that gives us a factor of x minus 2, and that's good because it matches some of these other factors. But what about this negative 1 hanging out down here? Well, with a fraction, you can put the negative 1 in the numerator or the denominator. So what I could do, and I'm going to do it right on this step, is I'm going to say, I'm going to put that negative 1 up there because it's the same. Remember, negative divided by a positive is the same as a positive divided by a negative. So you can put that negative in the numerator or the denominator. So just to clarify here, this becomes negative 2 over the quantity x minus 2. Okay, so that's what I'm going to write over here. Negative 2 over the quantity x minus 2. Okay, now we can start getting a lowest common denominator. And to find the lowest common denominator, I like to think about it as, well, what is missing from all of these denominators? The LCD. Well, we've got x minus 2, so 2 of those factors, and an x plus 2. So that LCD is going to be x plus 2 times x minus 2 quantity squared, or I like to write out both of them, x minus 2 times x minus 2. You can't just have one of them. You do need both of these here because we have both of them in this denominator. So now what is this missing? Well, this is missing the x plus 2, so we have to multiply both the numerator and the denominator by x plus 2. And I'm going to put some parentheses around the x minus 1 right away so that I don't forget that I need to multiply some FOIL here, right? The quantity x plus 2 times the entire quantity x minus 1. Now, I didn't leave myself a lot of space, but I've got to multiply another x minus 2 times this denominator and the numerator as well to multiply the numerator and the denominator. So x minus 2 here and x minus 2 in the denominator. All right, and now over here, this last rational expression, we are missing another x minus 2 and another x plus 2. So I'm going to put that x plus 2 and x minus 2 we're missing, which really we know is x squared minus 4 because we just factored that just a minute ago. But we'll multiply that on the numerator and the denominator. And just to save us some time here, I'm going to rewrite this x minus 2 times x plus 2 as our factored our multiplied form, and that is the x squared minus 4. And I'm just doing that to save us from rewriting all of this stuff again. So now I'm multiplying the negative 2 times the x squared and the negative 4. So I'm going to write all of this stuff out, and then I'll come back and it'll be all written out. So let's walk through what's happening here. I put everything over the lowest common denominator, because once you have a lowest common denominator, you just add straight across the numerators, and then you have the same denominator. But I should put some parentheses here. Let's do that just to keep it clean, or to show you what's happening here. So x plus 2 times the quantity x minus 1, that's what I did here. That becomes x squared plus x minus 2. And then this rational expression, the numerator there, becomes x squared plus x minus 6 after I FOIL those, or multiply those two binomials. And then likewise, negative 2 times x squared times negative plus negative 2 times negative 4 is negative 2x plus 8. So we have that in the parentheses. Now we can just simplify, and that is combine like terms in the numerator. So we have x squared plus another x squared, and again, these parentheses can just drop out now because we're adding everything. So we could just get rid of them now. I was just putting them there just to show what I did from the previous step. But now it's x squared plus another x squared minus 2x squared. Well, that's just 0x squared, right? Let's get some red ink and knock those out. Now we have 1x plus another x. That gives us 2x. So I'll write that in the answer, in the numerator, 2x. We've got also negative 2 plus negative 6 plus positive 8. Those are all going to get knocked out. We've got negative 8 plus positive 8 ultimately. So we just have 2x in the numerator. And in the denominator, we have this same denominator that we had, that we built up. So x plus 2, that quantity, times the quantity x minus 2, times the quantity x minus 2 again. This might be written as x plus 2 times x minus 2 quantity squared, just combining these factors, and that's fine. I like to just leave it all out to show it, also in case we need to do any canceling, in case there's anything in the numerator that we can cancel with the denominator. All right, so we took this large addition problem and just treated it like a smaller fraction, got the lowest common denominator, and then just added across the numerator, and then simplified, just combined some like terms. I hope that helps.